In this session, we are going to learn about what differential equations are and the order and degree of a differential equation. Hi, I am Syed. Welcome to my channel Educate with Syed. Let's get started. Suppose you have a equation of the form dy by dx plus y is equals to 0. This equation will be called as a differential equation. Any equation which contains the derivative of a dependent variable with respect to an independent variable will be called as a differential equation. Here y is a dependent variable and x is an independent variable. So an equation which contains the derivative of a dependent variable with respect to an independent variable along with few other parameters is called as a differential equation. Let us take another example. Suppose if you have d square y by dx square plus dy by dx plus y is equals to 0. So this equation is also a differential equation because you can find this y, the dependent variable, is being differentiated with respect to an independent variable twice. Here y is a dependent variable which is being differentiated with respect to x once. Now let us try to understand order and degree of a differential equation. Suppose I have a differential equation of the form dy by dx plus y is equals to 0. Here you can see that dy by dx is a first order derivative and y is a dependent variable. In this differential equation, we will try to see the highest order derivative. Here you can find that y is being differentiated with respect to x once. Therefore, it is a first order derivative and that itself is the highest order for this given differential equation. Therefore, the order of this differential equation is 1. We try to observe that dy by dx, the power raised to this dy by dx is 1. Therefore, this 1 represents the degree of the given differential equation. Let us take another example. Suppose we have a differential equation of the form d square y by dx square plus 2 times of dy by dx plus y is equals to 0. If you try to observe over here, this y is being differentiated with respect to x twice. So therefore this is the second order derivative. So here you have dy by dx, it is a first order derivative. But the highest order derivative is 2. Therefore the order of this differential equation will be 2. The highest order derivative represents the order of the given differential equation. I will try to see this is the highest order derivative and what is the power raised to this highest order derivative. The power raised to this highest order derivative is 1. Therefore, the degree of this differential equation is 1. Let us try to take another example. Suppose you have d cube y by dx cube plus it is 3 times of sine of dy by dx plus y is equals to 0. So here if you try to observe, dy by dx over here is the first order derivative. Here d cube y by dx cube, it is the third order derivative and this is the highest order. Therefore, the order of this differential equation will be 3. To understand the degree of a differential equation, these two conditions has to be satisfied. The first one is the differential equation should be a polynomial functions in the derivatives. So the derivatives dy by dx, d square y by dx square, d cube y by dx cube should be polynomial functions. The second one is the power of the highest order derivative gives the degree of the given differential equation. Now let's try to understand from here, is this dy by dx polynomial function? No, because along with sine you are having the derivative dy by dx. So therefore it is not a polynomial function. Therefore the degree is not defined over here. The degree is not defined. Therefore, for this given differential equation, the order is 3 and the degree is not defined. Let us consider this differential equation. Here we can find that the highest order derivative is 2. Therefore, the order of the differential equation is 2. And what is the power of this highest order derivative? The power of this highest order derivative is 1. Therefore, the degree of this given differential equation is 1. But if you observe in the previous differential equation, we have taken sine of dy by dx was not a polynomial function. But here sine of y is there. But the condition is not for the dependent variable, but the condition is for the derivative. So y is not a derivative, it's just a function. Therefore, the highest order derivative power, which is 1 over here, that itself will be the degree of the given differential equation. So let us try to find out the order and degree of this differential equation. If you try to observe over here, y triple dash represents the third order derivative. So we observe that the first order derivative y dash is nothing but dy by dx. Y double dash is nothing but d square y by dx square. Y triple dash is nothing but d cube y by dx cube. So here if you try to observe, the highest order derivative is of order 4. Therefore, the order of the given differential equation is equals to 4. If you try to observe over here, y triple dash is a third order derivative and this is not in the polynomial function form. So therefore, the degree of the given differential equation is not defined. Because sine is not in terms of the polynomial function. It is in the form of the derivative. Over here, y triple dash is in the form of a derivative. Therefore, the degree is not defined. Let us move on to the next question. The next question is y dash plus 5y is equals to 0. So y dash represents dy by dx plus 5 times of y is equals to 0. So here if you try to observe, this is a first order derivative and this itself is the highest order derivative. So therefore, the order of the given differential equation is 1. And if you try to observe over here, the power of this first order derivative, what is the power over here? The power is 1. Therefore, the degree of the given differential equation is 1. So we have the differential equation ds by dt whole power of 4 plus 3s square d square s by dt square. So if you try to observe in this example, ds by dt is a first order derivative. D square s by dt square is a second order derivative. Therefore, what is the highest order over here? Highest order is 2. The highest order over here is 2. Therefore, the order of this given differential equation is 2. Let us try to find out the degree. So we will try to observe over here, the highest order derivative is this. So what is the power of this highest order derivative? The power of this highest order derivative is 1. The degree of the given differential equation will be 1. But here if we try to observe, the highest power is 4. But we are not trying to see the highest power 4. But we are trying to see the highest order derivative. What is its power? So its power is 1. Therefore, the degree of the given differential equation is 1. The next example is d square y by dx square whole square plus cos of dy by dx is equals to 0. So here if you try to observe cos of dy by dx, so therefore the differential equation is not a polynomial function in derivatives, because cos of the derivative you are having, so the degree is not defined over here. So degree in this case is not defined. Degree is not defined. Let us try to see what is the order. The highest order derivative over here is 2. Therefore, the order of this differential equation is 2. The next example is d square y by dx square is equals to cos of 3x plus sine of 3x. So this differential equation is a polynomial function in the derivatives. So here you have the derivatives. Here you don't have the derivatives. So we can say that is a polynomial function in derivatives. Therefore, degree is defined over here. So let's try to find out the order and degree. So here the highest order derivative is 2. Therefore, the order of this given differential equation is 2. So what is the degree of this given differential equation? This is the highest order derivative. And what is the power for this highest order derivative? The power that is raised is 1. Therefore, the degree of the given differential equation is 1. The next differential equation is y triple dash whole square plus y double dash whole cube plus y dash to the power of 4 plus y power of 5. This differential equation is a polynomial function in derivatives. Therefore, the degree is defined over here. So let us try to find out the order and degree of the given differential equation. So the highest order derivative is y triple dash. Therefore, the order of this given differential equation is 3 because it is a third order derivative. And what is the power raised to this highest order derivative? The power raised to the highest order derivative is 2. Therefore, the degree of this given differential equation is 2. The next question is y triple dash plus 2 y double dash plus y dash. Here the given differential equation is a polynomial function in derivatives. Therefore, the degree exists over here. So try to identify over here y triple dash represents the highest order derivative. Therefore, the order of this given differential equation is 3. And what is the power raised to this third order derivative? The power is 1. Therefore, the degree of this given differential equation is 1. The next question is y dash plus y is equals to e power of x. This differential equation is a polynomial function in the derivatives. Therefore, the degree is defined over here. So let's try to find out the order and degree of the given differential equation. So y dash represents the first order derivative, and that itself is the highest order derivative. Therefore, the order of the given differential equation is 1. So what is the power of this highest order derivative? The power is 1. Therefore, the degree of the given differential equation is 1. The next differential equation is y double dash plus y dash whole square plus 2 times of y is equals to 0. This differential equation is a polynomial function in the derivatives y dash y double dash. Therefore, the degree is defined. Let us try to find out the order and degree of the given differential equation. If you try to observe, the highest order derivative is y double dash, which is d square y by dx square. So this itself is the highest order derivative. Therefore, the order of the differential equation is 2. And what is the power of this highest order derivative? Power is 1. Therefore, the degree of the given differential equation is 1. The next question is find the degree of the differential equation. So this is the differential equation that is given. But this differential equation is not a polynomial function in the derivative. So you can see this first order derivative is there in sine of dy by dx. So because of that, this differential equation is not a polynomial function in the derivatives. Therefore, here the degree is not defined. Degree is not defined. The next question is the order of the differential equation. 2x square d square y by dx square minus 3 dy by dx plus y is equals to 0. So here if you try to observe, the highest order derivative is the second order derivative, d square y by dx square. So that itself is the highest order derivative. Therefore, the order of this given differential equation is 2. The next question is y double dash plus 2y dash plus sine of y. Now this differential equation is a polynomial function in derivatives, therefore the degree is defined. So because here you have the first order derivative over here, here we have the second order derivative, so both are the polynomial functions. Whereas in this case, sine of y, this y is not a derivative. So y is not a derivative, therefore the degree is defined over here. So if you try to observe, y double dash is the second order derivative, therefore the order of this differential equation is 2. And the degree of this given differential equation will be, suppose if I raise what is the highest order derivative's power is 1. Therefore, the degree of the given differential equation is 1. That is the required solution. If you like my videos, please subscribe to my channel. Thank you.